Let's look at how we can graph the solution to this system of inequalities. So our first inequality, x squared plus y squared, is greater than or equal to 9, and our second, x plus y, is less than 1. We call this a nonlinear system of inequalities because our first inequality is not the graph of a line, though our second one is. So if we think back to previous chapters, that first inequality is actually telling us about a circle. So let's think about x squared plus y squared. If it had been equal to 9, this would be a circle that has a center at the point 0, 0, and it has a radius of 3. So the way that I'm coming up with this, if you think back to the very first chapter, the equation of a circle was given as x minus h squared plus y minus k squared is equal to r squared. So essentially in this equation, h equals 0, k equals 0, and r equals 3. So we're going to have a graph that's a circle centered at the origin at the point 0, 0. Since it's a greater than or equal to, we're going to do this as a solid circle rather than a dashed circle. So when we think about the greater than or equal to portion in our original inequality here, so greater than with a line, we said to think above. So you can still kind of imagine this idea of above, but here it's going to be going outside of the circle in every direction, so our shading will end up on the outside. We can still use the test point idea for a nonlinear system like this. If we check 0 squared plus 0 squared is greater than or equal to 9. We have 0 is greater than or equal to 9, which is false. So what this is telling us is that the part of the graph with 0, 0 will not be shaded. So let's look at how we could put this on our graph. So picture your center at 0, 0. We want to mark points that are a distance of 3 units away. So I'm going to go 3 units above, 3 units to the left, 3 units below, and 3 units to the right. And then connect those using a solid curve. And then we said we want 0, 0 to not be shaded. So the inside of the circle is not shaded. That means that the outside of the circle is going to be shaded. So go ahead and lightly shade on the outside, knowing that part of this is going to get erased and won't be part of our final solution set. But our final answer is going to be somewhere outside of our circle. So now let's come to our second inequality. We've got x plus y is less than 1. So this is a linear inequality. If I subtract x from both sides, I have y is less than negative x plus 1. So this is going to be a line. It's going to have a slope of negative 1. So it's going to go down 1 and right 1, down 1 and right 1, and a y-intercept at the point 0, 1. So m equals negative 1 and b equals positive 1. This one is going to be a dashed line because it does not have the equals option underneath. So if we go ahead and put this on our graph, I'm going to start at the point 0, 1 and go down 1 and right 1, down 1 and right 1. So it's going to cut through our circle and then connect our points using a dashed or dotted line going all the way across our graph. So thinking about where we should put our shading this time, if we look at our inequality, it was a less than symbol, so you can think about it less than as being below. We could also do our test point here as we've done before. If we plug in 0, 0 in the original inequality, you'd have 0 plus 0 is less than 1. So this time 0, 0 comes out true. So the shading should be on the side of the line where 0, 0 is. So less than is below, 0, 0 is below. So we're thinking about our shading being down below our green line. So if we shade in everything that is below the green line, we again are looking for where this shading overlaps. So the overlap of the red and the green shading is the part that's below the green line but is outside of the circle. So if we erase our previous shading, our final answer, kind of our final shading, is going to be everything that goes outside of the circle but stays down below our green line. That this would be the solution to the system of inequalities. So we're saying that if you pick any point from this shaded region, it will make both of our inequalities true. So a nonlinear system, we'll start to see some of our other families of graphs. We can have circles, parabolas, any of the other types of graphs that we know how to make, and we're still just looking for that overlap of the shading, what works out for both of our inequalities.